Hi, this is Gus. I want to talk to you today about the LCD keypad shields. This is a very common shield. This is an example of that shield that's made by Link Sprite. DF Robot make that shield as well. Other companies make them. And we also had created this shield a long time ago. We don't offer it anymore, but this is something we did like 5 years ago. I found this very useful when I build any project using one of our Fez boards. I'll show you an example. On Fez Cobra, there's the header on the back. So whenever I build a project, I choose to use the header on the back. I do the same on the Fez Panda. Those headers make it easy for me to build a daughter board or just run the wires to a breadboard, so I can build the project quickly and not utilizing the shield headers, the Arduino compatible headers that are right here, for example. And this frees that part to add shields. And this LCD keypad shield is one of the shields I use the most, since it gives me a small display. It's a character display, but it's enough to show some information about voltages, levels, what's happening while the project is running. And I have few buttons to use. There's only one thing to remember when using these shields. Most of the shields that I see on the market are made for 5-volt systems, and they do not work directly on our boards or any board that is 3.3 volts. Most of the new boards are 3.3, but these shields were made years ago when most systems were 5 volts. So when you connect, the display works fine because we still have the 5-volt output and the digital pins are 3.3 volts, but the display works at 3.3 volts. So there's no concern when it comes to the display. However, the buttons are not wired to GPIOs like you would expect. The buttons are wired through a resistor network to analog input 0. So all buttons are using one analog input. That's nice, but then they are analog levels, and this greatly depends on the voltage that is the voltage coming into the resistor network. And they are, on most shields I have seen, they are connected to the 5-volt line, meaning the output from when you press the buttons is over 3.3 volts. The buttons are not going to work. The fix is easy. I'll show you an example here. So looking at the schematic, the Link Sprite schematic for the part of the schematic of the resistor network, you can see how the resistor network is connected to the buttons, and then the top resistor is connected to 5 volts. We need that resistor connected still to the network on the bottom side, but then the top side needs to go to 3.3 volt line. The change is easy. So all I did was take this resistor off, find that one resistor on the schematic, find it on the board, take it off, and then solder it back to the resistor network. But then instead of soldering both pads, I'm soldering it sideways. So one side is connected to the resistor network. The other side is open free. Once that's done, I can add a wire, a really tiny wire from the resistor to the 3.3 volt line. And that's all I have to do. And now the network, the voltages, when I press the different button, the voltage can be 0.5 volt, 1 volt, 2 volts, any voltage between 0 and 3.3 volts. I can run a quick program that prints out the analog voltage from when I press the button. And I write these numbers down. So when I press, let's say, up, I read 0.5 volt. I write 0.5 volt down. When I press down, I read maybe 1 volt. I write 1 volt down for that particular button. And then in my code, I just check for that voltage plus minus some margin, because the button, it's an analog input. It's not going to be exactly the same value. It's going to be that value plus minus 5–10%. That's all I have to do to get it to write the driver for the buttons. The display, it's standard display. There are drivers for it everywhere for different platforms, and there's plenty of examples for that display on our website as well. Let me show you a quick demo of the display running. In the demo, I'm going to be using this shield, which this is the original one that we created about 5 years ago. This one, the resistor network is connected to 3.3 volt already. We don't need to make any modification to it. The other one will work as well. I can actually run it and show you both running. So let's plug it in. see right here. Okay, this is it. This is it running right now. I can press the buttons. All the program does, it's a simple program. The first line shows Fez's grades. The second line shows the button that's being pressed. So up, down, right, left, select. Using the other shield it's still the shield, the same pinout, everything is the same. However, the resistors that are used on the buttons may not be the same value, and they are not in this case. So even though I'm still connected to NLX 0, the up button on one shield might be half a volt, the other one might be 3/4 of a volt. So we need to check those voltages and adjust your driver accordingly. But here's the second shield running, the display is running as well. I hope you enjoyed this video. We'll see you next week.